Today, we're going to be talking about the mole diagram. This handy little tool is excellent when you have to do any type of conversion in chemistry dealing with moles. All right. Think of the mole diagram as like a road map. Okay. And the boxes are your destinations. All right, you're either going to land on mass, moles, particles, and sometimes volume. All right, so the boxes are your destinations. And so if you're using this road map, okay, and you're trying to, I'm going to cover up some pieces here. You're trying to go from mass to moles, okay, going from mass to moles. You can see in that direction, you will divide by the molar mass of the substance. If you have moles and you have to find the mass, see where you're ending up, you will multiply by the molar mass of that substance. Well, what if you had moles and particles? Now, particles can be atoms, formula units, molecules, ions, etc. Well, if you have moles, get that in there. If you have moles and you're trying to find particles, then you're going to multiply by Avogadro's number. If you have particles and you're converting that to moles, you will divide by Avogadro's numbers. There will be times where you guys have to travel the entire way vertically. I'm sorry, not vertically, horizontally. um, and what I mean by that is you may be given the mass of a substance, but you have to find particles. And so you have to go from mass to moles to particles. And so you would start with your given number, your grams of the substance, divide that by the molar mass, and then multiply by Avogadro's number. If you have particles and you had to find mass, then you would go from particles to moles, dividing by Avogadro's number, and then from moles to mass, multiplying by molar mass. All right, if you had, cover up these two places, what if you had moles and you were trying to find the volume of the substance? Well, if you had moles and you were trying to find the volume in liters, then you would multiply by 22.4, which is the volume at standard temperature and pressure. And if you had the volume converting to moles, you would divide by 22.4 liters. Okay, so that is what the mole diagram looks like. And what we're going to do is work some problems and use it. Okay, so let's look at our first problem. Unfortunately, I am going to have to take this out. If you have not copied this, go ahead and get a copy of this in your notes. All right, get a copy of this in your notes and use this as we're working the problems. All right, so here's our first example. Hopefully you're going to work this problem with me because it's always better when we do it together. All right, so here we go. How many moles are in 6.38 grams of H2O, which is water? Okay, so what we're going to do is we're going to figure out what this problem is asking us to find, okay? You're given mass. Okay, so this is what you're given. And you're finding moles. So let me bring back my diagram. You're given mass. You're finding moles. You're given the mass. You're finding moles. How do you do that? Yeah, you divide by the molar mass of the substance. You will always start with your given amount. So it'll be 6.38 grams. You can put the H2O. I like putting that just so I know what I'm dealing with. And we're going to divide that by the molar mass of water, which is 18.015 grams per mole. All right. Last little thing that needs to be done is the actual division. You put 6.38 divided by 18.015. You get 0.354 moles. All right, did you get that? Good. Let's look at the next one. All right, this one says how many molecules are in 18.93 grams of carbon dioxide. So I'm like, okay, what is happening here? Oh, well, let's do this first. 18.93 grams is mass, and we're going to molecules, not moles, but molecules. Okay, so we're going from mass to particles. All right, just jump right in there with a long one there. We're going to go from mass to particles. So the first thing I got to do is take my given mass divided by the molar mass. That will give me moles. And then I'm going to multiply by Avogadro's number. So 18.93 grams of carbon dioxide. Divide that by the molar mass of carbon dioxide. So that would be the mass of one carbon plus two hydrogens. All right. And then I'm going to multiply this by Avogadro's number. Yes, I'm just excited all of that fit on the page. And so when you do this, you take your 18.93, divide that by the molar mass, and then multiply by Avogadro's number, and you get, I'll put the answer up here, times 10 to the 23rd molecules. All right, and so that is how many molecules that are actually in 18.93 grams of carbon dioxide. All right, we have one more example that we're going to go through, and this one is how many liters are in 4.2 moles of oxygen gas. So here I am, and I'm going from moles to liters, which is volume. So I'm going to go from moles to liters, and I'm going to multiply my given by 22.4 liters. Okay, so it's going to be 4.2 moles. Oxygen gas, oxygen's one of the 7 diatomic elements, so it's going to be O2. And I'm going to multiply that by 22.4 liters, and I get 94 liters of oxygen. Okay, how did you do? All right, so if you have any questions, let me know. And that's about it.